lesson is about the verification of quadrilaterals. On the screen, you'll see we're going to look at two examples for a parallelogram and a rectangle. Let's first look at the parallelogram and how do we prove that a certain quadrilateral is a parallelogram. When we talk about parallelograms, they have distinct features that separate them from other quadrilaterals. Well, first of all, we talked about that opposite sides are parallel, hence the name parallelogram. And also, opposite sides are equal in length. So, opposite sides are equal in length. Now, the one distinct feature that separates a parallelogram from a rectangle or a square is the fact that adjacent sides do not form 90-degree angle. While the sum of all angles in this quadrilateral is still 360, adjacent sides are not perpendicular on one another. And because of that, it really helps us separate parallelograms from quadrilaterals, from rectangles. So let's look at our examples. It says prove that ABCD is a parallelogram where A, B, C, and D are the given vertices. Now, since we do have the coordinates of all the vertices in this quadrilateral, I'm going to tackle first the first property of this quadrilateral, which is opposite sides must be parallel. Now we know that parallel lines have equal slopes, which means we have to find the slopes of all the sides and see if the opposite sides have equal slopes. But also for this first verification step, we also have to prove that adjacent sides are not perpendicular. And that is very important because in all respects, a parallelogram is a rectangle without a 90-degree angle. So we really have to prove that adjacent sides are not perpendicular. So let's take a look at our slopes. A has the coordinates -3 and -3. B has the coordinates 9 and 3. C has the coordinates 12 and 8. And D has the coordinates 0 and 2. The formula that I want you to apply for slope is M equal y2 minus y1 over x2 minus x1. And at home, what I want you to do is calculate the slopes for AB, which should be equal to the slope of CD, and the slope of AD, which should be equal to the slope of BC. And in the process of calculating all the slopes, you will also notice that the slopes of AB will not equal the negative reciprocal slope of BC, since AB and BC are adjacent. You'll also notice that the slope of AD will not be the negative reciprocal of CD, and so on. Now, for the second verification property, we talked about that in a parallelogram, opposite sides must be equal. So, using the length of the line formula that we have learned in the first day of this unit, which is length equal square root of y2 minus y1 squared plus x2 minus x1 squared, you have to find the length of AB, BC, CD, and AD and prove that the opposite sides have the same lengths have the same measurement. Once you go through the two verification steps, you have proven that this quadrilateral is a parallelogram. Now let's take a look at verifying a rectangle. We have a quadrilateral PQRS that we have to prove it is a rectangle. So I have P, Q, R, and S. And we have to prove that this quadrilateral is a rectangle. Now, as we went through the parallelogram's features, I want you to do the same for a rectangle. In a rectangle, all the angles are 90 degrees. And as soon as I see a 90-degree angle, I have to think about perpendicular lines. And what is the property of perpendicular lines or perpendicular sides? Is negative reciprocal slopes. In the process of finding the slopes of adjacent sides and proving that PQ is perpendicular on QR, that SR is perpendicular on QR, and that PS is perpendicular on SR, we will also find out that PS is parallel to QR, since opposite sides have to be parallel, and we'll also find out that PQ is parallel to SR. And remember, parallel lines have equal slopes. So in the first step, what I want you to do is find the slopes of all the sides and show that adjacent sides have negative reciprocal slopes. And as I said, in the process of finding those values, you will also prove that opposite sides are parallel. Now, for your second verification, what separates a rectangle from a square or from a rhombus is that opposite sides have similar lengths. Not all the sides have the same length. So using the length of the line, formula, you will prove that the length of PS is the same as the length of QR, and that the length of PQ is the same as the length of SR. Remember my tips for starting word problems and really any kind of proofs in analytic geometry. When you draw your diagram, identify your points on the graph and label them with the values given to you. It will help you visualize furthermore what every point is defined by. So P is 3 and 9, Q is 12 and 6, R is 8 and negative 6, and S is -1 and -3. And also on the graph, for the people that still have a bit of trouble keeping track of their x's and the y's, identify your x1s and y1s. So x1, y1, x2, y2. So for QR, since Q is the second point, we can name R the first point, so this can be x1, y1. And S will be that second point now, it's x2 and y2. If you label them this way, especially in the first few times when you're doing work problems like this one, it will help you keep track in the slope formula, in the length of the line formula of your x's and your y's, and will minimize the potential mistakes that you can encounter. I really want you to take the time at home and finish both problems and verify if these quadrilaterals are a parallelogram and respectively a rectangle.